Okay, so let's talk about this. So in problems like this, they're asking us to do three things, right? Okay, they want us to write the inverse of that function. Not a big deal. There's a lot of practice on this assignment doing that, and that's not hard to do. The harder parts, I think, and they're not very hard, are parts 2 and 3. We want to write the domain of the inverse function using inequality notation, and in part 3, oops, it's frozen. Okay. Part 3, they want us to write the domain of f of x, the function, so that it's invertible. Now, what's that word mean, invertible? When you add IDL to the end, or ADL, it means, it gives you the ability to do something. What's that? To find the inverse. Yeah, to invert a function is to find the inverse, right? So this is the same thing as saying, take the inverse of all, right? Let's think about what that means. We had a discussion before break about what it means to be able to have a function that's going to have an inverse, right? So let's sketch this. Let's sketch this. We want to do a sketch of this graph, and from that sketch, we'll see if we can predict whether that function is going to, whether its inverse is going to be a function or not. And if not, what do we have to do to change it so it will be, right? So this brings us to another little bit of a discussion that I want to talk about anyway today, and so now's a good time. How do we do a sketch of a function like this? So this takes us back, this is review. We did a lot of this stuff earlier in the year. If we've got some parent function, f of x, and we want to tweak this. We want to do some transformations to the parent function. We're going to define some new function, call it g of x. So I want everybody to write this in your notes as we do this. I want to know what are the ways that I can tweak the parent function f of x to do anything I want with it, right? And we came up with, at the beginning of the year, we had a list of parameters, and we could choose values for those parameters, which would tweak this in a bunch of ways. Okay, what's one of the parameters? We had, like, for example, h was one, right? What's another one? K. Okay, so there's two. What's another one? A.
B.
And then B was the other. B was the one we didn't use very much, but B was the fourth. So there were 4, right? Now, where do they go? Where does A go in the function when we're? Okay, good. It goes out front. So A goes out here, and then times the function. Where does H go? Okay, in the parentheses, and it's subtracted from x. Very good. Okay, so we've got f of x minus h, right? Okay, and then we've got a plus k out there. Where does the b go? That was the one that was a little bit odd.
Does it go under?
Yeah, it goes inside the function in front of the x stuff, right? In front of the x minus h. So we'll put it, how about right there? And b goes on the bottom, right? It's 1 over b. It's the reciprocal of b that goes there. So now let's just make a table. Let's write down what each of those things does. What does A do? Okay, stretches it or compresses it vertically or horizontally? Vertically. Okay, so A is vertical stretch, or so that's the first thing it does. Vertical stretch or compression. Okay. I want to do this. So this is A. Second thing it does, what if A is negative? What does that do to the function? Okay, it reflects it vertically, right? Okay, if A is negative, so it's less than 0, it reflects vertically, right? Okay, what about B? What about B? I'll give you a hint. B is a lot like A. Same stuff, but horizontal, right? It does all the same stuff, but it's just horizontally. So if we take our B, it can horizontally stretch or not reflect, or compress. And what if B is negative, what does it do? How does it reflect it? Horizontal, yeah. Okay, good. Okay, so there's what A and B do. Now, I'd say that H and K kind of go together too. What does H do? These were maybe the easier ones. What does H do? It translates it in which direction? Left and right. Good. Good. So H only does one thing. It translates left and right. Okay. That's it. What does K do? Yeah. That's pretty bad, K. Only does one thing. Translates up and down, and that's it, right? Okay, so then let's take that stuff and let's apply it to that function. Okay, so if f of x equals x squared minus 7, and we're starting with the parent function, x squared, what does x squared look like, first of all? Parabola, just parabola with the vertex where?
Negative.
Well, this one does, but just plain old x squared, the parent function would be where? It's 0, 0, at the origin, right? So what's being done here? Well, there's nothing out in front, so A is 1, right? It's not being reflected vertically or stretched or compressed vertically. There's nothing inside the squared function that's being multiplied by x, so B is 1. There's nothing being subtracted from x inside the function, is there? Right? It's not like the quantity x minus 3 squared or something, right? So H is 0, good. And then the only thing that's being done is we're adding negative 7 to the end, so what's K? Negative 7, right? Because we're adding K, so we're subtracting 7 is adding negative 7, right? So then we know if we want to sketch this thing, we'll just go 1, 2, 3, 4, 5, 6, 7. That's where we're going to move the vertex of our parabola, right? So it's just going to be right there with coordinates 0, negative 7, and our parabola just does that, right? Everybody agree? Okay, so that's a sketch of f of x. Now let's think about the inverse, right? If I want to be able to invert this thing, well, I can take the inverse of anything, but the question is it going to be a function? If I take the inverse of this, I've got to reflect this whole thing over the line y equals x, because that's the line of symmetry, right? I reflect over that line. So what happens if I reflect over that line? Let's just reflect a couple key points. This point right here at 0, negative 7 is going to reflect over the line to negative 7, 0, isn't it? Everybody agree? And think what we do when we find an inverse, we're just switching the domain and the range, right? So if this is 0, negative 7, then this is the point negative 7, 0, right? Okay, what about this point? Let's take, for example, this point right here. Where would that one go? Well, that one's going to go right up there, isn't it?
Yeah.
It's going to reflect right across. And so what's this going to look like then? It's just going to go like that. Okay, but what's the problem with that red graph?
Does it pass the line test?
It does not pass the vertical line test, does it? Now, the blue function did. It passed the vertical line test, so it was fine. It was a function, but the red one does not. Okay, my question is, if we backtrack here a little bit, so let's undo that red function. How could we have predicted right there that the red function was not, the inverse was not going to be a function? Okay, what test does the blue function fail that predicts the red one's not going to work? The horizontal line test, right. So what is the horizontal line test? Well, the horizontal line test, all it's telling us, it doesn't mean that the blue relation is not a function. It is. It passes the vertical line test. But it means when I take its inverse, it's not going to pass the vertical line test, right? So one way of thinking about this is, in order for f of x to be invertible, there's two other ways we could describe that we've talked about. One way is we could say that it's 1, 2, 1, right? For each input, there's exactly one output, right? And that's not the case here. In this case, I've got many to one. I could have two different x values that give me the same y value, right? For the blue function. So it's not 1 to 1. It's many to 1. We need it to be 1 to 1. Another way of summarizing that is that it passes both vertical and horizontal line test. It's got to pass both. This one doesn't. So what do we do? What did we say that we did before the break then? If it doesn't pass both, what do we have to do to that blue function to make it 1 to 1? Remember? What do we have to do? We got to get rid of one, don't we? We have to get rid of the bottom one of the red, which corresponds to the left one of the blue, right? So in order to make the blue function pass both tests, we're just going to go back and erase the whole left side, right? So now when we're left with just the right side, this one does pass both tests, doesn't it, right? Now if I were to reflect just the right side of that parabola, I end up getting this function right there, and that's okay, right? Does that make sense? Okay, and remember, this is what a square root graph looks like too, which we'll get to later, right? Okay, so then we don't even need to graph the inverse. We don't even have to do it. All we have to think about here is, if I'm going to limit the domain, if I'm going to erase part of that function, what is the domain of f going to be? Tyler, what are we going to get? If I erase that left half, what part did we keep? What's in the domain then? Okay, but now you're thinking range. That's a y value. Domain is x values. 0 is where it starts, and then which way does it go? Okay, to positive infinity. So the domain is going to go 0 to positive infinity. Another way of saying that is all values of x greater than or equal to 0, right? Okay, so there it is. What's the range going to be? What are the y values? Is there a lowest or a highest y value?
Yeah.
There is. What's the lowest y value? Okay, so then it's going to be everything above -7, right? Okay, so there's the domain. Does that make sense based on our sketch? Okay, and really, both of these were limited, and they both started or stopped at the vertex, right? That's the point that's the lowest point, and when we erase half of it, it's the leftmost point. It's where it starts horizontally also. Does everybody understand what I mean by that? Okay? So then here's my question. What?
And what's R stand for?
Range. Domain and range. Okay? So what about the inverse function then? Without even graphing it. Don't even have to do it. Without even graphing it, what's the domain going to be? No? Yeah, it's going to be this. Because think what we do. An inverse function in a function, all we've done is just switch the domain and the range. Switched x and y, right? So the domain is just going to be now all values greater than or equal to -7. And the range is going to be all values greater than or equal to 0. Which we can kind of see in our graph, can't we? Right? If I look at the values graph, didn't we say that this point right here was -7, 0? So we're taking all the x values, -7 and to the right, and all the y values on or above 0, right? But we didn't even have to graph it. We can just get it all by flipping those. Yes, ma'am?
So for the domain, so the first domain would be the -7 infinity, and then the second domain question would be 0.
Yes,
What if
exactly.
we switched it? Would that be wrong?
It'd be wrong, because
Okay.
the second one wants the domain of the inverse function, which is the same as the range of the function, right?
Right.
Okay, it wants that written as an inequality, so how would I write that as an inequality then?
-7 less than or greater than 0.
So x is what relative to -7?
Great.
Greater than or equal to, right? Okay. So this would just be x is greater than or equal to -7. And the domain of the function, to make it 1-to-1, to make it pass both line tests, was just that, right? They wanted using interval notation. So it looks like that. Okay, what about, now the first part's really the easiest. How do we do the first part? What are the 3 steps that we have to do to find the inverse of a function? So we start off, what's the first thing we do?
Switch x.
Okay, well first we're just gonna, it's a really small step. First thing we're gonna do is just rewrite it with a y instead of an f of x, right? So we get y equals x squared minus 7. Now what? What's step 2? Ashley, what's step 2?
Switch x and y.
Switch x and y. Good. Okay, so step 2, we're gonna switch x and y, so it becomes y squared minus 7 equals x, right? And then finally, step 3 is probably the bigger step. We have to just isolate y, solve for the new y. So what are the steps in order? Jasmine, what do I do to get that y by itself? First well, hold on. What do I have to do? I have to follow reverse order of operations, right? So I add 7, and then I square root. Okay, so that would give me y squared equals x plus 7, and y equals the square root of x plus 7. But what do I need to include? Anytime I square root both sides of an equation, what has to be included?
Plus or minus.
The plus or minus. Does the plus or minus make sense now, too? Right? In our graph, this part right here is the square root of x. What do you think this graph down there would be? Minus the square root of x, right? So there's both parts. There's plus the square root of x or minus the square root of x. So it all works out, so the graph matches up. Now, the math gods are pretty crafty. They wrote it as 2 separate answers because together it's not a function, but separately each one of them is, right? Positive the square root of x passes the vertical line test, and negative the square root of x passes the vertical line test. But which one do we always keep? We're going to keep the plus one because we kept the convenient or the positive side of the parabola to begin with.
So in Moodle, you only put the plus.
Right, so in Moodle, we would not put the minus. We wouldn't even have to put the plus then, would we? We would just write the square root of x plus 7. Okay? Make sense? Okay, so what about, now this one should take about 2 seconds. Whoops, let me get rid of this. What about that one? Maybe more than 2 seconds, but not much. What are the answers to 2 and 3? Yeah.
Wouldn't it be 6 positive?
Okay, but what kind of function is this?
Cube.
It's a cubic function. So what is it? Well, now think about what the parent function for a cubic function looks like. A quadratic function is this. What's a cubic? Like that, right? Okay, so that's right now that one. If I look at that one, okay, all that does is it's going to go up on the right and down on the left, correct? If I add 6 to it, I'm just picking up that middle section. The point that used to be at the origin just gets moved up 6, right? So 1, 2, 3, 4, 5, 6, and here's my function. Right? It just goes over 1 and up 1 and backwards 1 and down 1. But what about that? What about that function right there, f of x? Does it pass both vertical and horizontal line tests?
Yes.
It does. So do I have to restrict the domain or erase anything? In other words, I do not. Okay, so then what is for f? What is the domain? Negative infinity to positive infinity. It's not at all restricted, right? It goes forever to the left and forever to the right. Brandon, what's the range? Y values. What Y values are negative to positive infinity? It's not restricted vertically either, is it? Right? Okay, so then, without even graphing it, what's going to be the domain of the inverse? What's the domain of the inverse
It's
going
gonna
to
be
be?
the exact same thing.
Yeah. The domain of the inverse is the range of the original one, right? So they're getting switched, but they were the same to begin with anyway, right? Whoops. Okay, make sense? Good? So these are easy. These are just unrestricted, right? How would I write that as an inequality for the domain of the inverse?
X is
Greater than negative infinity and less than infinity. Good. The domain of the function, the interval notation, just looks like that. Okay, so see if you can do all this in your head. What's the answer going to be for the inverse function then? If I change that to a y, I flip the x and y and solve, what are you going to get?
Y equals the cube.
Cube root of x minus 6, right? Because this would become, right, this becomes a y, and then when we switch them, we get y cubed plus 6 equals x, so I subtract 6 and then cube root. Everybody agree? There it is, okay?
I have a
Piece of
question.
cake. Yes?
So the x is greater than negative infinity, but less than positive.
Less than positive
That
infinity.
goes to the second domain.
Well, these are the same thing, but they wanted it written as an inequality up here,
Okay.
so that's why we wrote it that way.
And so that goes for answer 2.
The answer 2 is the same thing, right? Because there's the domain of the function, there's the
So
domain
then
of
which one do you plug into?
both, because it wants both. It wants, part 2 wants the domain of the inverse.
Okay.
So that's this. See what I'm saying?
So you don't write. Yeah, but I'm asking which one do you write in there? That's what I'm confused about. Okay, never
The
mind.
domain of f is negative 1.
No, you understand?
Kind of. But like,
Well,
okay, so I get that you write the equation for number 1. For number 2, do you write the inequality answer that you put up there on the line?
part 2 wants to know, so here's how we look at this. We know from our sketch, we know that the domain and the range of the function are both unrestricted. They're both all reals, right? So I know that the range, without even graphing the inverse, I know that the range of the function is going to become the domain, which is the answer to part 2 of the inverse.
Okay.
So whatever I get there with x's in it instead of y's is going to be the answer to part 2,
Okay.
right?
Yeah.
Does that make sense?
Yeah.
Okay? All right, so I want you to do this one. Do that one. Oh, I'm gonna change it though. That's too easy. You guys are way too smart for that. Way too smart for that.
Oh, come on.
Do that. Okay, go. Quick. Okay, let's go. Just go. Great this out. You got it.
Square root of negative.
Okay, what about the? I want to see the sketch. What's the sketch gonna look
Oh,
like?
it's right here. So you guys, get your parabola going down.
Oh, that's good. That's good.
And then your other one's going this way.
Okay. Now, which one do you need to get rid of?
That, this one.
No.
No?
Unless you
No, you need to get rid of the left.
Unless you do this right though.
So it's gonna end up, get rid of the left one, it's gonna be like that.
Minus. Oh.
I feel like this is a trick question.
Gage, what's up? Question? Let me see if you got it
Is this?
right. Yeah, good, very good. The 6-0. Yep.
Question,
Yes.
so I'm
So you want to do that? Or is it in there?
Okay, it's gonna be
Okay.
you're gonna have negative.
Oh, negative
right.
x, what is it, plus 6?
So it's gonna be negative x, yeah, because you're gonna distribute it, aren't you? Right, because you
Yeah, because-
subtracted 6, and then you multiply by
Well-
negative 1.
Well, okay, yeah, okay, so it is, well, because I divided everything by negative 1 to get rid of that.
That's fine, that's fine.
But you still get positive 6,
Okay,
right?
but then the other side would be negative 2. Because you have to multiply both sides by negative, which is fine. That's good. So, but you gotta do the same thing to both sides. You just didn't do it to this side.
Yeah, so now that's a negative.
There you go, good. That's it. Mhm, that's good. Yep, very good.
So is the 6 positive then?
What's that?
So the 6 is positive.
Yes, it is. Yeah. Okay, let's go. Let's have a look. Let's have a look. Okay, Caitlin. What's, yeah. I want to know here. Okay, what are the two things that are being done to the parent function x squared? Well, okay, not that, I'm just saying, I mean, if I want to sketch this graph, instead of f of x equals x squared, we've done two things to that to change it. Like one of them is we added 6, right? What's the other thing?
Wait, what?
Okay, we multiplied by negative 1, didn't we? Right, so what are these things? Let's identify what's going on. So adding 6 is the same thing as saying, okay, k equals 6, right? Everybody agree? So that just moved it up by 6, didn't it? Now, what about this negative in front? That's like saying a is negative 1. If a is negative 1, what does that do to the function? Okay, so it's reflecting it vertically, so instead of opening up, it's opening down, right? So when we sketch this, all we have to do is k is 6, so the vertex is going to be up 6, right? Instead of being at 0, it got moved up 6. But then the function is opening downward, right? So it's doing that, right? So those are the coordinates of the vertex. So Adas, which one are we going to, what do we have to do to this function here? Because right now it doesn't pass both tests, right? It fails the horizontal line test. What do I need to do to the function so it'll pass the horizontal line test? Good, we got to erase half. Which half are we going to erase? Left. We're going to erase the negative half. So that part goes away.
You
Good.
always erase the negative.
Yep, you always erase the negative part. Okay. And so now what's the domain? So here's my function f. What's the domain going to be? Yes.
Isn't it 6?
Okay, the domain.
Okay, well 0
Okay, so it's going to be all values of x.
less than 6.
No, you're thinking y, right? This point right here has an x value of 0 and a y value of 6. So what are going to be the x values on this function after I erase half of it? 0 to,
Negative.
to positive infinity. Because I'm, horizontally speaking, the n is starting here at x
right.
equals 0, and as he walks this way, his x value is increasing, isn't it? Right? Okay. So Maisie, there's the domain. What's the range going to be this time? The y values, yeah, okay, go ahead.
Wait, y value?
Mm-hmm. The x values were all the values at or to the right of the vertex. The y values would be where relative to the vertex? Okay, so 6 is important, right? That's the y coordinate of the vertex.
So it's 6 to negative infinity.
Ah, good. Does that make sense? So it's everything 6 on down to forever, right? So I just write that as negative infinity up to and including 6, right? Or another way of saying it is y is less than or equal to 6, right? Okay, so then what about the inverse? Because that's what we want to answer. Part 2 is the domain of the inverse. So what's based on the domain and range of the function, what's the domain of the inverse function going to be?
6.
Okay, so right, all values less than or equal to 6. So, right, you see what I'm saying? We don't even have to graph the inverse.
I have a
this is what its domain is gonna be.
So why is there negative infinity on the other side? Is it because negative infinity is less?
Well, because it's like a number line.
Oh.
Negative infinity is infinitely far to the left, positive infinity is infinitely far to the right. So we gotta go from left to right. So left, clear over to the right up to 6. See what I'm saying?
Yeah.
Okay. So if I want to write that as an inequality, what's that look like?
Negative infinity.
Okay, but as an inequality, so not using interval notation, but as an inequality. Caitlin, what's that gonna look like if I turn that? That's what I gotta put there, but I gotta write it as an inequality. So x is what? Less than or equal to 6. Good. Good. And then the domain for the function, well, that's just right there, right? And they wanted an interval notation. So, like that. Now, what about the steps for part 1? So we'll just follow the rules, right? Step 1 is we're going to rewrite it in terms of y. So y equals negative x squared plus 6. Now we'll flip the x and the y, so that becomes a negative y squared plus 6 equals x. And so now there's a couple ways we could do this. If we want to follow order of operations to solve for y, think what that means, right? We're going to isolate, so we go bottoms up, or bottom up. Don't confuse that with bottoms up. So we go bottom upward. First, add or subtract. Is there anything we need to add or subtract to both sides to isolate y? Yeah, we'll subtract 6, right? So the first step would be negative y squared equals x minus 6. What about multiply or divide? I think I need to multiply or divide both sides by to get the y by itself? What? Negative 1. Either multiply or divide. It doesn't matter, does it? If I multiply each side, how about by negative 1? Those cancel, right? And I get y squared equals negative x, negative the quantity x minus 6. If I distribute the negative, I get negative x plus 6, right? Make sense?
Yeah.
Okay, so now last step would just be to square root both sides?
Yep.
Right? So we get y, go down here. Y equals plus or minus, but we'll take the plus, the square root of negative x plus 6. Or if I want to, I could just leave it as the square root of negative the quantity x minus 6. Either way is fine. Okay? Make sense?
Yeah.
Okay?
And that's to the right.
All right. Okay, last thing, then we're out of here for the day. Okay? So before we leave, let's get through one last thing. So what about this now? This is a great place for us to stop. This is related to the stuff we talked about with all the transformations, all 4 of those parameters, a, b, h, and k, right? Only this time, instead of writing it in terms of some generic function f of x, where g of x is written in terms of f of x, they tell us what f of x is. It's a square root function. Okay, so then what am I going to do here? What is this telling me? If I'm going to vertically compress f of x by a factor of 1/5, what is that telling me? What parameter is affected by that?
Isn't it h?
A. It's A. A is the one for
Oh, right.
compression or stretch vertically, right? So that part is telling me that A equals 1/5. What about this part right here? If we want to reflect it over the x-axis, so that's going to
It'd
be,
be negative.
okay, that means A is negative, doesn't it? So that's telling me that I've got a negative in front of it. But that's all that stuff is saying, right? So then if I want to tweak f of x, which is the square root of x, what's g of x going to be?
Negative 1.
Yeah, that's all it's going to be, is negative 1/5 times f of x, which is the square root of x. Right? You see that? Okay? All right, one more. Just like that. How about this one? If I want to horizontally stretch by a factor of 4, what's that doing?
That's changing.
That's changing b, isn't it? Right? That's a b issue. So if I'm going to horizontally stretch by a factor of 4, that means b equals 4, right? So then g of x equals the square root of, the b goes inside, right? b goes inside the function. So that's going to be 1 over 4, because b is 4, times x minus h, but there is no h, so just times x, right? And if I simplify that, there's something I can do to this. If I multiply, what's 1/4 times x if I write that as a fraction? So 1/4 times x over 1, I just multiply straight across. It's x over 4, right? So I get the square root of x over 4. How can I simplify that? What can I do if I have the square root of a fraction? What can I do?
As a better like reciprocal.
No, but I can split it up, right? Like, what if I wanted to do the square root of 4/9? Separate question. What's the square root of 4/9? What do you think?
2/3.
It's 2/3. How'd you get that?
Square root of 2, square root of 9. Or square root of 4, square root of 9.
Yeah, I just split it. Square root of the top over square root of the bottom, right? So it's 2/3. So what's this going to be then? I've got the square root of x over the square root of 4. So if I wanted to, I could even write this as the square root of x over 2, right?
The whole thing over 2 or just x?
The whole thing, square root of x all over 2. That's fine. Honestly, the one Moodle wants in this case, the best answer is really that answer, because that tells us that the 4 is inside there, and so it's a value of b, right? So I was just showing you that you could simplify this further, and it tells you something kind of interesting. Here's the last thing I want to point out. So what if we did something like this? If I wrote this as 1/2 times the square root of x, or the square root of x over 2, isn't that the same thing as 1/2 times the square root of x? Okay, what does that look like? Does that look like an A or a B? That looks like an A. That looks like an A with a value of 1/2. So think about this. B equals 4 turns out to be, when I do the algebra, the math gods are telling me that that's the very same thing as B, or sorry, not B. A equals 1/2. That makes sense. A horizontal stretch by a factor of 4. So imagine I take a function and I stretch it by a factor of 4 horizontally. In this case, because it's a square root function, that's the same thing as a vertical squash by a factor of 1/2. How about that? All right, get out of
Wait,
here.
I have a question before I
Yes.
take that test. I have everything else 19. If I want to go over 2 problems that came up from the practice test that I couldn't figure out.
Okay.
So it's those 2 problems.
Okay. Yeah. Let me turn this off.